I hope you will get a better idea from, I mean, during the quiz one exam actually.
Sir,
So,
one thing that I wanted to share,
mhm,
till week 2 it was very okay for me, but
mhm,
from week 3 onwards, there means I am not even able to do some of the activity questions. Those are very conceptual based, and I think that many things have been encapsulated.
mhm,
Like if we have to calculate the variance, and
mhm,
if we say variance of x, that
mhm.
doesn't mean the single x, it means that entire values of x, right? And sir took some small problems like uniform distribution and everything,
Mhm.
but how to calculate those on means formula is there, but
Mhm.
sometimes we have to apply logic. There are some of the questions that I was doing, and I found that we need to use those formulas for that. So can you please clarify on that also?
We'll discuss those where
Okay,
you
sir.
are facing difficulty and all. We'll discuss. Don't worry. Okay, let me share my screen. Meanwhile, any one of you can tell me what do you understand by the expectation as per the knowledge of Statsman or something else or
Long run average.
Long term average.
long term average? Okay, anybody else?
The weighted mean of the probability and the outcome.
Okay, anybody?
Basically it's taking the value and multiplying it with their probabilities
It's the
and take all
okay.
the summation.
That's the procedure, right?
Mm-hmm. It just means if we try to do something for a long term, what
Mm-hmm.
is the probability that we will be getting? What is the
Okay.
chances?
Okay. So basically, okay.
So it's
Suppose
the center of the probability distribution. I mean, the
Yes.
center value of the probability distribution.
Hmm.
yes. Okay. Correct. So suppose I have let's say I'm considering one random variable. Okay. So how I can define my random variable? So I'm defining my random variable like probability my mass function if it's discrete, correct? If it's continuous, I will use probability density function. That will be discussed later. Let's come to the PMF, right? So how we are defining the probability mass function? Suppose x is taking value some x, right? So x1, x2, and so on, xn, and along with each values, there are some associated probabilities, right? Probabilities are associated, right? And all the probabilities should be greater or equal to 0. Sum of all the probabilities should be equal to 1. That is something. Suppose I want to describe my random variable. Okay, so that's the something I have to do, correct, to describe one random variable. Okay or not?
Yes, sir.
Okay, so what expectation tells us, suppose you want to describe your random variable in a single number, right? Rather than doing all the things, all the writing all the values, range of x and probabilities associated with each values of x. Suppose I want to describe my random variable in a single value, correct? So that's I can do with the help of expectation or not. So one of you told me that it's a central value, right?
Yes, sir.
So that means what? If I'm telling the yeah expectation of x is this, that means I have some central idea about my random variable, right?
Yes,
If
sir.
I'm describing my whole random variable within a, I mean, with the help of one value, not all writing all the ranges and all the probabilities and all the conditions and all, right? So are you getting the idea? And someone of you told me it's a long run average, correct?
Yes.
That's also correct. Okay. So basically, long run. What is the meaning of long run average?
So if we
If something
do
is
the
happening over a
if
long
we do
time.
the activity for long time,
Mhm.
we will get this probability, this value.
Uh, yeah. Suppose I'm doing the experiment large number of times. Okay. The average of the right results of the experiment I can expect as the what you can say average of I mean in simple term you can say it's a theoretical average, right? Theoretical average of as you can say long run average, correct? Are you getting the idea?
Yes, sir.
Okay. So how I can define the expectation? So suppose since we are studying only about discrete random variable so far, so suppose x is the discrete random variable and it has some range. Okay, so expectation of x can be defined as the summation of x into px, right? This is something which we have done, right? Suppose x has the range tx, right, and is taking the value something as something t1 t2 and all. So what I can do, in formal notation I can say t belongs to t of x and t into fxt. So this is the values, this is the value taken by the random variable x, and this is the probability associated with this value of x. Okay, so this is something we are defining the expected value of a random variable. Okay, so is this clear to all of you?
Yes, sir.
Yes, sir.
Okay,
So that t is individual value, right?
t is the one of the value which is taken by the your random variable x.
Okay, and fx of t is the
Probability
probability.
associated with that value.
Okay.
Okay, so I think in lecture 3.1 it syllabus is about expected value of some of the distributions also, right?
Yes.
So let me do one of the distribution. After that we'll go further. Okay, which distribution you like? Uniform, should I do uniform or Poisson or
I have
geometric
one question.
or binomial?
So geometric.
Sir,
Geometric, so
Yes.
sir,
Geometric.
sir, T here in this formula, T is one of the one of the value of random variable.
Yes, yes.
If that value is zero, suppose T takes the value zero,
Hmm.
then zero, then some value will be lost from the expected value.
Okay. Suppose x is taking value 0, 1, and 2, right?
Yes, sir.
And I'm assuming probabilities for each value. It's you can say, let's say 1 by 3. Correct?
Yes, sir.
It's a correct valid PMF. Sum of all the probabilities is equal to 1 also, right?
Yes, sir.
Now, so suppose I want to asking, tell me expected value of x, right? Then what
Yeah.
I have to do? I have to multiply it by value into
Probability.
probability associated with each associated with that value, right?
Right.
So what you have to do? 0 into 1 by 3
Yes,
plus
that is 0.
1 into 1 by 3 plus 2
Yeah.
into 1 by 3. So again you will get 3 by 3, which is 1. Okay,
Okay.
clear?
Okay.
So
Yes, sir.
yeah, in simply we have to, what we have to do, we have to see the, we have to multiply each value with the corresponding probabilities. That's all. Okay, as per the definition. Clear?
Okay, sir. Yes, sir.
Yeah.
Clear.
So geometric will be enough for everyone. Geometric distribution.
Yes, sir. It is. Yes, sir.
Okay, okay. If you want any other, for any other distribution, let me know. Okay, we'll discuss it. Okay. Suppose I'm saying x is following geometric distribution. Let's say with probability p. Okay. So what is the PMF for this? Okay, what basically geometric distribution tells us? Anybody? In which scenario I want to I will use the
The first
geometric
success. Probability of first success.
first success.
probability of.
First
First
success.
success.
After
Yeah.
repeated trial, the
Then
first
tries.
success.
Okay. So what will the PMF for this?
T into
So okay, what is the meaning of probability of x equal to t?
yeah,
What is the meaning of this here? Means I will get the first success in the tth trial, right?
right.
Yes, sir.
Correct. That means you are getting the I mean failures till t minus one trials. Correct.
Yes, sir.
That means
Yes.
what failure means. If this is success probability, then what is the probability for being failure? 1 minus p,
One
right?
minus P.
So you are failing till t minus one trials, right? And you are getting the your first success in tth trial. Correct.
Yes.
So it will be 1 minus p raised to power t minus 1 into p. So you can use in the place of t, k and all anything, but funda should be clear. So what should be the range of t? It can be 1, 2, 3, so on, right? So
Yes, sir.
far it is clear to all of you?
Yes, sir.
Yeah. Now tell me, what is the expectation? How did we define the expectation? Expectation nothing but summation of t, I mean belongs to tx, I mean throughout the range of x, t into fxt, right?
Yes, sir.
Correct. So what are the values taken by your random variable x? It's a 1, 2, and so on, right? So if you put 1 into, what is the probability? It will be 1 minus p raised to power 1 minus 1 into p,
Only P.
correct? Plus 2 into 1 minus p raised to power 2 minus 1 into p.
Yes, sir.
I mean, is this okay for everyone?
Yes.
Yes, sir.
Okay.
Yes, sir.
Yeah, just let me know if you are facing any difficulty here. So 3 into 1 minus p raised to power 3 minus 1 into p, correct?
Yes, sir.
Because see, are you getting, this is 1 values into probability, then 2 into probabilities, plus 3 into probability, and so on, right?
Sir, up to this line is okay, but in the in the GP series, I
Hmm.
am unable to solve that.
I will come to that. No, no worries. Okay. So can you see P is the common, right? From, so what we got here, 1 minus P raised to power 0 plus 2 into 1 minus P plus 3 into 1 minus P square. Similarly, we can do 4 into 1 minus P raised to power Q and so on. Okay.
Yes, sir.
So P 1 plus 2, 1 minus P. See, this is power 0. So something power 0 will become 1, right?
Yes.
Plus 3, 1 minus P square plus 4, 1 minus P cube plus so on, right? So we have to find out the value for this quantity, right? So how we can proceed? This is the funda here. So let's do it separately. Suppose this is I'm making it as considering as S. Okay. So 1 plus 2, 1 minus p plus 3, 1 minus p square plus 4, 1 minus p raised to the whole cube plus so on. Right? Now, what we can do the next step?
Sir, it's a GP, right?
It's a GP, right?
So, can we separate the constant and separate the P in separate
Okay.
bracket
So
and
what I
then
can do? Okay. What I can do? Can I multiply
So
it
we
by
can shift the series, right?
1 minus p into s? Correct? If
yes,
I
Yes,
will
sir, we can.
multiply, sorry,
I mean, sir, yes, sir, we can
we
actually.
can,
I
yeah,
mean,
yeah.
yeah, that would shift the series by one term to the right.
Correct, correct, correct. That will be simple for us actually. So if you multiply it by 1 minus p to each terms of it, then what you will get? 1 minus p, correct?
yes, sir.
So that 1 minus p, okay, okay. Let me write down. What I will get? 1 minus p, right? Let's make it as the equation 1 plus 2 times 1 minus p square, it will be right, plus 3 times 1 minus p cube, right?
Yes, sir.
It will be like that or not?
Yes,
Correct?
sir.
Now, just write the equation first again. 2, 1 minus p plus 3, 1 minus p square plus 4, 1 minus p cube, so on. Second equation I have 1 minus p times s is 1 minus p onwards, right? So you can write down the 1 minus p here, right? Plus 2, 1 minus p square plus 3, 1 minus p raised to power cube plus so on, right?
Yes.
Now, if you subtract these two equations, what I will get? S minus 1 minus p times of s, right? 1. This from here you will get 1 minus p, 2 minus 1, right? From here you will get 1 times 1 minus p square, correct?
Hmm.
So 1 minus p raised to a whole cube. So far, so good for everyone.
Yes, sir.
Yes, sir.
Now, from here I can take
Sir, in the
1 minus.
last step, what you did?
Hmm? I have subtracted the elements of these two equations.
Okay.
Okay. So from here, if you take not 1 minus s, if I will take S as a common, what I will get on the left hand side is 1 minus
1 plus P.
correct. Okay, so what is this? This all the terms on right hand side. It's something kind of, if you see carefully, it's a 1 plus R square plus R cube and so on, right?
Yes. 1
So
upon
what is the equation? I mean,
A upon 1 minus
1
R.
upon 1 minus R, right?
1 upon 1 minus R, yes.
Simply, right? So for this right hand side, what I can write? 1 upon 1 minus R. So in the place of R, I have 1 minus P, correct?
P.
And this left hand side, I got P times S, correct? So P times S equal to 1 upon, again it will become P,
Yes.
right? So what
Yes.
I got, what you will get from here? 1 S equal to 1 upon P square, right? Correct?
Yes, sir.
So S equal to 1 upon P square, what is your S? S is this whole things, right? So what will be your expected value? So expected value of X will be P into 1 upon P square. So it will be 1 upon P. So mean for the, I mean, expected value of a geometric random variable is 1 upon P. It is clear to all of you?
Sir, can you scroll a little bit up?
Yes, sir. Little bit.
Okay. This.
Yes, this
Yeah.
S into
I'm
1
fine.
minus 1 plus P. Means
Mhm.
what we did here.
It's a simply right, simple things. Just subtract 1 minus 1 plus P. So 1 will get cancelled out. You will get 1
Yes.
by P.
No, not there. S
Ah.
into. Okay, so you are writing P in terms of 1 minus 1 plus P, like you did in the
P in
denominator.
terms of? No. In the place of R, I have 1 minus P, right?
No, sir, I am not asking about that.
Ah,
I am
ah.
asking about this
This one.
LHS. That part, yes.
Okay, so it's a C. It's a simply one gate will get cancel out. We get
So
P
it's a
times S.
manipulation by our own, means we didn't got it by subtracting or anything.
No, we got by subtracting here. I think you are not coming here. If you subtract S minus 1 minus P times S, so from here I can take as a common, so I will get 1 minus P. Okay, 1 will get cancel out, you will get P times of S.
S.
So that P times of S will be 1 upon P.
Hmm.
But we have to find out the value of only S, right? We are interested
Hmm.
to find it. So S will become 1 upon P square. Okay. If
Okay,
you
sir.
put 1 upon P square, so 1 P will get cancelled out. At the end, you will get 1 by P. Okay.
Okay. Okay.
Clear to all of you? Okay, so similarly, you can find out the expected value of any random variable. Okay, so should we move to the concept of week lecture 2, or any doubt from activity 3.1? If you have any doubt from activity 3.1, then we can discuss it, or else we can discuss the concept first. No one?
Sir, question number 3. 3.1.
Question number activity 3.1, right?
Yes.
Okay, a coin is biased such that head is likely to occur 3 times more than a tail. Find the
Tail.
expected number of heads when the coin is tossed twice independently. Okay, so how did you approach? When what?
Sir, here the coin is biased. So it says that coin is biased and head is more likely to occur 3 times more than tail. So I took the probability of tail as X and head as 3X.
Okay.
But I know that a normal coin has the probability of half. So 3 times of half will be 3 by 2. And
Okay, so
But after that, I
no,
was
no,
not
no, no. Is this probability then? If you are doing 3 times half,
Hmm.
then it's a 1.5. 1.5 is possible.
No.
See, question is all about any one of you.
Here head will be 0.75 and tail probability, and tail probability will be 0.25.
Its expectation is binomial, so like you can just say NP.
Hmm.
Okay.
So
Okay.
2 into 0.75, which gives you 1.5.
Yeah, or by logically you can go like this. It's a saying probability of head is 3 times,
Three
right?
times
More than a tail. So let's assume for getting tail, probability is P. Okay. Suppose probability of T is P, right? Then probability of head will be what? 3 times P, correct? That is the something. And you know sum of all the probabilities should be what? 1,
1.
correct? So
Hmm.
4 times P equal to 1. So we got P equal to 1 by 4. That is 0.25, right? So for
Okay.
probability of head, it's a 0.75, and for probability of tail, it's a 0.25, correct? Now,
Okay.
what you are doing, we are tossing the coin 2 times, right?
Yes.
Correct? So tossing the coin 2 times. So what it will be? X will be binomial with 2 comma 2 comma
0.75.
0.75.
0.75, sir.
Right, because I'm interested in the number of heads, right?
Heads, not tails.
So
Yes.
what will be the expected value of binomial? NP.
Okay. NP, yes, NP.
So 2 into
0.75.
0.75, which is
1.5.
correct. Clear? Okay.
Sir, last question.
Any other doubt from activity 3.1?
Sir, last question.
What is the last? Okay, what is the doubt in this?
Sixth. Actually,
Six is not last, right?
sorry.
Okay. So question is, suppose a game is to be played with a single bias die. The numbers from 2 to 6 are equally likely to land face up. That means probability from 2 to 6 are same, right?
Okay, yes.
Okay.
But one is not same, right?
But number 1 is thrice as likely to land a face for each of the other numbers.
Numbers.
Okay. So that means what? Question is saying for 2 to 6, right? Let's say
Hmm.
probability of getting 2, probability of getting 3, so on. Probability of getting 6 is same,
Yes.
correct? But probability of getting 1 is 3 times P, correct?
Hmm.
Now, so where is that? One second. In the game, a player wins 100 rupees if 3 turns of 150 if 5 turns of, and he will lose 160 if 4 turns of, right? While the player neither wins nor loses if any other phase turns up, find the expected money to be won. Okay. So what is the value of P first of all? How will you proceed?
You can sum up, so
3p plus
3p
5p.
plus 5p.
Correct. Means we know some of all the probabilities should be 1, right?
Yes.
So 3P plus 5P equal to 1. I mean, if you add 2 to 6, it will be P plus 5 times, right?
Okay. Yes.
So it will be 8P equal to 1. So from here I will get P is equal to 1 by 8, right? So what
Yes.
is the expected value? Okay, he will, okay, so P is equal to 1 by 8. That means probability of getting 3, if 3 turns up, probability is 1 by 8, right? Or 4 turns up and so on, right? But for P, if 1 turns up, so probability will be 3 by 8.
3 by
But
8.
that's not our concern. Our concern is about he will win 100
It's
rupees if 3 turns
100.
up, 150 if 5 turns up, 160. I mean, he will lose 160 if 4 turns up. That means what? Means 100 into 1 by 8
Yes.
plus 150, right?
150. Yes. 150 into 1 by 8.
Minus 160 into 1 by 8. Why I have done minus 160?
So he loses money, right?
He
Correct.
So
loses.
it,
He
it would be
loses.
negative.
Yeah,
Yes. He
he
loses
loses the
160
money.
if 4
That's
turns up.
why. So if you solve, you will get the correct answer. Okay.
Sir, means that 1 by 8 is basically the probability of 3, 5, and 4, right?
Yeah, that's the expectation, right?
But it says expected money to be won, only won. We will not take the losing part, right?
One second. Suppose you are playing a game, okay?
Hmm.
I said you will win 100 money, 100 rupees if 3 turns up,
Hmm.
okay? And 154 turns up, and you will lose 160 if 6 turns up. So I was asking expected money you will own means how in the total at the last how much
Okay.
money you are getting. I mean you are expecting to win, right?
Hmm. Hmm, hmm.
So I mean suppose you own at the end, let's say 120 rupees.
Hmm.
Just assume. So that means it is also included your how much money you have loses, right?
Yes.
Okay. So that's why it's asking about expected money to be won. Okay.
Okay, and
In
I was not subtracting that minus
in
160.
throughout the game. Okay, clear? Is this clear
Correct.
now?
Yes, now it's clear, sir.
Okay, so is the pace is okay for everyone? I mean, this
Yes.
agenda is clear. I mean, like that, lecture wise, activity wise, or should I do all the lecture and then I should take doubts from your side?
No, sir, this one is fine.
This all fine? Okay, okay,
This is good, sir.
Yes, sir.
okay. No problem, no problem. Okay, so lecture 2 is about properties of expected value. I think you guys are very much familiar to these kind of things, right? So properties of expectation, or you can say expected value. Okay. So tell me, so one property, the expected value of a constant is what? Is the same, right?
Same.
And and some of other properties are there. Like suppose you have a function of a random variable. Okay. Suppose I have a function of a random variable. Function of a random variable. Suppose I have random variable x. Okay. Then I ask what is the random variable, what will be the expected value of random variable y if y is defined as, let's say, x square plus 3. Correct? That is the function of random variable. Okay. Then what will be the expected value of y? Let's say
E
2x
of x
plus 3.
square plus 3.
So
Then
say
2ex plus 3.
correct. 2x plus 3.
2x plus
So it
3,
will be
yes.
2 times. Okay. So
E of x
okay.
plus
Funda is
3.
expected value of 2x plus expected value of 3. But I know expected value of constant is the constant. So it
Constant.
will be 2 times expected value of x plus 3.
3.
So that is the something I can find out the expected value of the function of a random variable. Okay. The same thing we can do if I have some constant multiplied by random variable. So I can do c times of expected value of x, right? The same thing which
Yes,
we
sir.
have done in the
Yes,
above
sir.
one, right? Correct.
Yes.
One more thing. Tell me, suppose I have two random variables. Okay, expected value of x plus y. Then what it will be?
Expectation of x plus expectation of y.
Yeah, like
Expected
some of
value of sum of,
separate
Sum of
expectations.
E
expectations.
of x plus
Yeah.
E of y.
and this x and y can be any two random variable, right?
Yes, sir.
Yes, it's
Yes,
They
not
don't have to be
required to be
independent.
independent.
This there is no need of being independent and all, but in case of variance it should be independent, right?
Independent.
Yes, sir.
Okay.
yeah,
So
otherwise 2 into covariance term would be there.
correct,
Yeah, yeah.
correct,
To
correct, correct,
subtract that.
correct. So that's all on the variance is there in this lecture, right?
Yes, sir. Yes, sir. Yes.
Yes,
I
it is
mean,
there.
not in this. Next, maybe.
Next. So and the same thing, if I will multiplied by any constant a times x plus b times y, then it will be a times of expected value of x plus
Sir,
b times
can
of,
you please repeat what you told about the independence? How it will affect?
I will come to that point. So in case of expected value, right? This is something called linearity. In case of expected value, it's there is no need of x and y being independent. While in case of variance, let me tell you will get. If suppose I'm writing variance of x plus y, right? So if x and y are independent, then only then I can write variance of x plus variance of y, right? If x and y are independent. Okay. If x and y are not independent, there will be one terms of related two times of covariance of x comma y. Okay.
Yes.
I will come to that point. Okay. No worries. So, and in this lecture also there is one concept of zero mean random variable, right?
Yes, sir. Standardizing and zero.
Yeah. So it's by the terminology, it's I hope it's clear. So zero mean random variable means suppose I have a random variable and expected value of that random variable is zero. Okay. So that's called the zero mean random variable. Just suppose it's nothing too much here. Suppose I have one random variable x and expected value of this random variable is zero. That means this this random variable will call the you can treat as the zero mean
Zero mean.
random variable. That's all. And how I can get the zero mean random variable? Means suppose I have random variable x, okay, and with something expected value of x, right? If I will subtract x minus expected value of x, okay, let's treat it as y, then expected value of y will be 0, correct or not?
Yes, sir.
Yeah, correct.
Correct, because see, expected value of y will be what? Expectation of x minus expected value of x, correct? So it will become expected value of x minus expected value of x, right? So this is
That's a
again
constant.
expected value of x minus expected value of x, which is 0. So here y is the zero mean random variable. Okay. Why it's called zero mean random variable? Because y is the random variable such that expected value of y is 0. Okay. That's the definition of zero mean random variable. Means we are doing something centering kind of things. Okay.
Sir, I have a question. I
Huh?
tried to do this using some of the values, like taking the dice example and everything. I got it. But here it says E of y, right? That is
Mm-hmm.
expected value of y. So
Mm-hmm.
that means that whatever value that y, our random variable y, after the function is computed, it
Mm-hmm.
takes times the probability that it will take that value. I took it like that and I didn't got that zero means. So how expected value is playing that part? in
Can you repeat? Can you repeat? Can you repeat your part? Is there any question you're talking about?
No, it is not a question. I just try to see that yes, this is true, but not
Mm-hmm.
like this. I took
Mm-hmm.
some values, say from 1 to 6, roll of a die, and took
Okay.
it like uniform,
Mm-hmm.
and I calculated the expected value, and then I
Mm-hmm.
subtracted each value by the mean, that is the expected value, and that I
It's
took
the
as y.
probability.
Yes,
Okay, so expected value is what? For this, it will be
3.5.
3.5.
3.5,
Okay.
yes, sir.
Okay. Okay, no problem. Yeah.
Now when I calculated this x minus e of x, everything got cancelled, right?
Everything got cancelled. Why?
1 times 1 minus 3.5,
Hmm.
2 minus 3.5, that way. So
Okay.
negative and positive.
Okay.
So everything got cancelled and I got 0. So where did e of y played the role?
Okay, so
Expected
1
value.
minus 3.5 what? 2.5 minus 2.5,
Minus 2.5, yes.
correct? So it will become minus 2.5 with the probability 1 by 6.
Yes.
It will become minus 1.5
Minus
with probability,
1.5, 1 by 6.
correct? And
Mhm.
what's the next?
It's 0.5, minus 0.5.
Minus 0.1 by 6,
Mhm.
correct? And 3 4 minus 3.5, right?
It's
So it
zero
will,
point 0.5 again, and it will repeat like 1.5 and 2.5.
correct.
Hmm. So
So
whatever we do,
yeah, so your expected value of y is 0.
but here means this x minus e of x calculation,
That's
that was
okay.
our y.
That is the y, right? Means if you see x minus expected value of x, right? This is
Hmm.
the y. What you do, what you done, you have centralize your random variable, right?
Hmm.
And
Hmm.
centralize your random variable means you will get expected value of that random variable as 0. That means this is the zero mean random variable. That's all.
Okay.
Okay.
So,
You have done the same procedure in the earlier steps. Okay.
yes, got it.
Got it. Okay. 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 So Any question from
So I
activity
have, yeah,
3?
I have one, not from activity, from
Huh?
here, what you have.
Okay, yeah, please
So
go ahead.
expected value of x, how to compute that thing? Yeah.
This one.
Yeah.
Okay, any one of you wants to take
Expected
that?
value of x is a real number or a number, constant value. So expectation of a constant is a constant. So that's the thing. E of x would be E of x, since
Okay,
the
okay,
inner E of x is a real number or a
okay,
constant.
okay. From here you can see expected value of x is 3.5.
Yeah.
If I want to find the expected value of x here, that means expected value of 3.5, right?
It's a
And
constant. Yeah. Okay.
expected value of a constant is c, right?
Same.
Okay, that's why I did not emphasize there. I thought you guys got it. Okay, no problem. Okay, any question from?
So question number 3.2.
I think you had only doubts, right? No one is asking. Think everyone has solved this question.
Yes, sir.
Yes, sir.
Yes, sir.
Okay, no problem. Question number 2, right?
Yes, sir.
What is the difficulty? It's a simple concepts are given to you, right?
I took it like since probability of x equal to 2 and x equal to 3 are same,
Huh?
so I took it like x and means 2x will be there, right? And probability
2x?
of x equal to 4 is y. I took it like y because it's different.
Hmm?
So 2x plus y, and then I applied the expected value rule like 2 into x plus 3 into x plus 4 into 4 into y is equal to 3.4. I think that is that
See,
right?
what is your y? If you are doing x, so
Hmm.
instead of x, y is not 1 minus something. Okay, so see, try to apply the basic concept. That's why I always saying whenever you are going to solve any question, okay, so
Hmm.
try to write all the things which are given. Okay, I mean don't do the things directly. I mean, if you are doing it directly, if you are able to do directly, that's good. Thing is that if you are writing all the steps, that means there is very less chance of making the mistakes. Okay, so x is what? X is taking value 2, 3, 4, right? X is value taking 2, 3, and 4, and it says probability for x equal to 2 is same as probability x equal to 3.
Hmm.
Correct? And it says what is the probability of x equal to 4? It is asking, correct? And expected value of x is given to us as
3.5.
3.5.
Yes. Wait a second.
3.4, sir.
3.4, sir. Yeah.
Okay. You see, probability of x equal to 2 and x equal to 3 is same. So can I assume, let's assume for 2 it's a p, for 3 it's a p,
Hmm.
correct? Then what should be the probability for 4? We know sum of all the probabilities should be equal to 1.
1.
So p plus, let's say you were saying x, right? Let's say
Hmm.
x equal to 1, right? So x is what? 1 minus 2 times p.
Hmm.
So probability of this will be 1 minus 2 times p,
Hmm.
right? So you have values of x and you have probabilities, right? Now,
Hmm.
what is the expected value of x? It's a
Sum of all the values times their
that means
probability.
2 into p plus
Hmm.
3 into p plus 4 into 1 minus
1
2p, which
minus.
is same as 3.4. It's given to us, right?
Yes.
So what you can do, it will be 2p plus 3p plus 4 minus 8 times p equal to 3.4. Okay.
Hmm.
So I'm not going to solve here. What you can do, you can find out the value of p from here.
Yes.
Okay. After that, what is the probability for x equal to 4? So probability for x equal to 4 is 1 minus 2p. So just put the value
Just
of
put the
p.
value. Okay, sir. Got it.
Clear?
Hmm.
Okay. Is there any
This
other
part I
question?
was not doing. This p plus x.
No problem. Is there any other question?
Sir,
Huh?
sir, I solved question number 6. Okay. Okay,
Question
same question.
number 6.
6.
Okay.
So I got this one. So I added k, all k equal to 1. Then I found k equal to 1 by 20. Then I found one
K is equal to
multiplied.
what? I mean, you added all the probabilities, right?
Yes, I added all
Ha
the property to
ha
find the k
ha
first.
ha.
Then I found k is equal to 1 by 20.
Okay.
Then for finding e of x, then I multiplied 1 multiplied by 6 by 20
Okay.
plus
You
2
have added all the
plus
probabilities of.
all. Yes. So I
Great.
found ex 2.3.
Okay, great.
But for the second part, find e raised to z. Sorry,
Expected value of a z.
Expected z expected. So I don't know, means I am stuck here.
Okay,
Also stuck on 8th,
Okay,
7th and
no
8th.
problem, no problem. So as we discussed a few minutes before, as you can see, what is the expected value of x plus y?
Expected value of x plus expected value of y.
Right. And
Yes.
what is your z in that case? X plus y, right? So
Z
expected value of z, that means expected value of x plus y.
X.
That
Yes.
means it's same as expected value of x plus expected value of y.
Y.
Right?
Okay.
Expected value of
Okay.
you have computed in the previous one.
Yes.
For the expected value of y, what you can do this
I will calculate.
all the rows,
Okay.
right?
Yes. Yes.
Okay. Now
Yes.
get it? Got it?
Yes. 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 Yes.
Now
And then
you
eighth one, sir. The
eighth one. Yeah, so it's the same as, right? So now x square plus 3xy. So z is x square plus 3xy, right? So
Yes.
expected value of z means what? Expected value of x square plus 3xy, right?
Yes.
Now what you can do, it will become expected value of x square plus 3 times expected value of x into y,
Yes.
right? So what
Yes.
you can do, you have to square the values of x, right? I mean you have x is you have 0, 1, 2, right?
0, 1.
0, 1, 2 for the x, right?
Yes. Now for eighth question, it is
Okay,
different.
one second.
Yeah.
So for x, what are the probabilities for 0? 0 0.25, 0 0.50, 0 0.25, right?
Yes.
0 0.25, 0 0.50, 0 0.25. This is the probabilities. Now you have to do x square, right? So what will be x square? 0, 1 and 4.
Sir, this question, no, sorry, for question 8 I am talking. X is only 0 and no 0, 1, 2. Correct.
X is
Yeah.
0, 1, 2. Y is 0,
Yeah.
1 only, right?
Yeah. Sorry,
So
yes.
x square means 0, 1 and 4, right? Probability will
Yes.
be same, correct?
Yes.
So from here you can find out the expected value of x square.
0. Okay. 0.
Correct.
Okay. 0. Yes. Okay.
Now
I
you
understood.
have to
Yes.
find out the expected value of x into y. So what is the definition of expectation? Expected value of xy means you have to
Expected
do
value.
x into y into probabilities, right?
Yes.
Correct. So you have to
Yes.
consider all the values, means 0 into 0, then 0.10, 0 into 1, 0.15, plus 1 into 0, 0.20, 1 into 1 plus, I mean into 0.30 plus, like that.
Okay. I
Got
will
it?
do. Thank you.
Okay,
Yeah, I got it.
just
Thank you, sir.
do it. If you are facing any difficulty, you can post it on Discourse and all, or you can ask.
No, I will try. Thank you,
Okay,
sir.
sure. Anybody else from activity 3.2, or should we proceed further? No one? I think what's are the in activity lecture 3.3 and 4? Anybody can tell me? Hello? Variance is
3.3 is just Python simulations in Python.
okay. And 3.4?
Variance and standard deviation.
Okay. Just okay, variance and standard deviation. Okay. So variance is what? Variance of random. Okay, basically tell me, can anyone of tell me what is the meaning of variance, or what variance tells us?
Spread of
It's the spread of our
Random variable from the mean value or expected value.
From the mean value.
Expected value.
As you have seen, spread around the central value. Yeah. So if you see the formula of variance, if you see, let's say consider the population variance. So what we are doing, summation of xi minus x bar square, right? So we are saying
Yes,
the spread of each value from its central value, from its mean. Okay. So in the for in case of random variable, you can define it as variance of x is same as expected value of x minus expected value of x whole square, right? This is the same thing. Or else you can say expected value of, if you expand this one, you will get expected value of x square minus expected value of x whole square. Is this okay, this one, or this is okay
Yes,
for
sir.
Yes,
everyone?
sir. Yes,
Yes,
sir.
sir.
Okay. So this is something variance is defined. Okay. What about okay? So what's the need of standard deviation if variance is there? It's nothing but just a square root of the variance, right? Then
to
what's
make
So
the
it
the
makes the
unit
units
same.
correct.
units
It's a
correct?
unit, sir.
Yeah, great, great. Because suppose your random variable x is like let's say height of person, right? So if you find, so original data is your in, let's say in feet or centimeter. Okay, maybe let's consider your original data in, is given in terms of centimeter. If you will compute variance, you will get the answer in terms of centimeter square, right? Let's say I'm getting the variance of that data set, let's say 72.5 centimeter square, something like that. Just assume some random value, centimeter square. But if you compute the standard deviation, then you will get square root of these things in centimeter, right? So it's easy to compare the things when final result will be in the same unit which is in original, which is for the original one, right? Original data set. Okay. So that's the standardization comes into the, that's why standardization comes into the picture. Okay. So this is something variance of x is defined for a single random variables. So I'm assuming after this properties of variance is there, right?
Yes, sir.
Okay. So let's do, okay. What are the properties for the variance of any one of you?
A variance of ax plus b is a square variance of x.
Okay, first of all, what is the value of variance of a constant?
Zero.
0.
Why is that?
Because
So it's a straight line on the graph, so we cannot spread it. So it's zero.
We can't spread it. And by mathematically, any,
mathematically expectation of x
aha,
square will be a square
correct,
and then
correct.
a whole square. So it
Yeah,
will just
San is
cancel
also
out.
right. San is also right. So by intuition, you can say there is no spread, right? And by mathematically, you can say expected value of uh, like that a square
Expectation of a square plus
minus,
expectation of a whole square would be
correct.
same.
So this will be a square minus this will become again a square, which is 0, right? So variance of a constant value is always 0, right? So second is let's say variance of a times of x, right? So a times of x, so it will become a square variance of x. So should I derive the things, or is it okay for everyone? Hello.
Okay, sir. Okay, sir.
Okay.
Okay for
It's
everyone.
fine, sir.
Okay. You can, what you can do, just put the ax in place of x, right? Then you will get a square outside, right, at the end. Okay. So next property is let's say suppose I'm saying variance of a plus x. What it will be? Variance of,
Variance of x.
okay. So what you can do on your own, just put the in the place of x, just put the a plus x. Okay. So next property I can say, suppose okay, let's consider about two random variables. Okay, two random variables. So suppose I'm saying variance. What is the what will be the variance of x plus y if I'm not giving any information about x and y, independence of x and y.
Then, sir,
So
the
if
covariance term would be there
covariance
alongside the
term,
variance of x plus
right,
variance
it
of
will
y.
become variance of x plus variance of y plus 2 times covariance of x comma
X
y.
comma y.
Now suppose I'm saying if x and y are independent, right? So what become if x and y are independent? So there are two kind of things. In case of x and y are independent, expected value of x into y become the expected value of x into expected value of y,
Why?
right? Since expected value of x into y is same as expected value of x into expected value y, due to this covariance of x comma y will be 0.
Yes, sir.
If covariance of x and y are 0, if x and y are independent, then this term will be 0. Then only then we are getting variance of x plus y same as variance of x plus variance of y when x and y are independent. Is this okay?
Yes.
Yes,
Okay.
sir.
So
Yes.
why we are doing like this? Because see, covariance is defined as expected value of x into y minus expected value of x into expected value of y, right? If x and y are independent, then expected value of x into y will be expected value of x into expected value of y, right? So this is something. So you will get covariance as 0. If covariance is 0, then it's something. And one important thing is there. Anyone of can tell me if covariance 0, then what does this mean? What is the meaning of this?
It means that they're independent.
The variables are not correlated.
Not correlated.
Correlated in terms of what? Linearly or anything?
Literally.
Linearly, sir.
Not
Linearly, right?
correlated.
It can be correlated. There may be some dependency in terms of other way, right?
Yes, sir.
Okay, because covariance tells us linear strength of two random variable, right? Linear association basically. Linear association between two random variables x and y. If covariance 0, that means x and y are linearly independent, right? That doesn't mean x and y are not dependent. There may be cases like y, there is a relationship y equal to x square and covariance you are getting a 0. Are you getting my idea?
Yes,
Yes,
sir.
sir.
Okay. So don't get confused like covariance is 0, that means x and y are independent. No, they are not linearly associated, but there may be some dependency between x and y random variable. Okay. Okay, so should we do the derivation of this one, or is it okay for everyone? Then we can move ahead.
Please
No?
move ahead, sir.
Okay. 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 No problem. So, any question from activity 3.4? Any one of you? Any doubt?
Sir, first question, I was able to do it, but means the value that I am getting is wrong.
First question. Okay,
I
the
calculated
probability
the
that
expectation.
Nidhi will earn uh, 2000 on a particular day is 1 by 4. Okay, so for 2000, your probability is 1 by 4, right? And
Yes, sir.
probability that Nidhi will earn 1500 on the same day is 3 by 4.
Hmm.
So what is the variance of the amount Nidhi will earn on? Okay, so it's simple. You have to compute expected value of x and
I
expected value.
calculated like
Uh-huh.
2000 into 1 by 4
Uh-huh.
and 1500 into 3
3
by
by
4.
4. So I think 4500 plus 200. So it's the 6500 divided by 4 is the expected value, right?
6500 divided by 4. I was not getting like that something.
What did you get?
I applied the variance rule.
It's expected value. I'm talking about expected value. Expected value will be 6500 divided by
Okay,
4, right?
yes, you are joining both, right?
Okay. And what will be the expected value of x square?
That calculate, I have to calculate.
Okay, so just calculate it. I think you maybe you are doing some minor mistake, calculation mistake. So expected value of x is you have to do 2000 times 1 by 4 plus 15,000 times 3 by 4, right?
Hmm.
So that's 6500 divided by 4. What is the expected value of x square? That means 2000 square divided by 4 plus 15 is 100 square divided into 3 by 4, right?
Yes.
So what is the variance of x? So just calculate this value and subtract this expected value of x square minus expected value of x whole square. That's all. Okay. Just recheck your
I have to
calculator.
do the calculation again.
Just check and okay. You can check it later also. Okay.
Hmm.
So I had a doubt in the third one.
Third one. Okay. What is
Yeah.
doubt?
I'm not understanding how to go about this. Like x minus y.
I mean, you had done. You are getting zero value,
Yes.
but
Yes, sir.
answer is 18, right?
Yes.
Yes.
Okay.
And the covariance value would be negative, but it's like a plus b whole square. So a square plus b square. It's like this variance of
Yeah.
x plus variance of y. Only the term which would be minus or plus, it would be the covariance term. If it's variance of x
Yes.
plus
Yeah.
y, then
Yeah.
plus
That's
Right.
2
Right.
into
Right. Yes.
covariance
Yes.
of
Yes.
xy, and that's the
Correct.
thing.
yes. And
Correct.
but you can do it from it directly if your random variables are independent, right?
Mm.
So
Yes, sir.
okay, so here you have to do variance of x minus variance of y, right? So that the Sayan
Yes,
said
sir.
that's absolutely correct. Great, Sayan.
Ah.
So what the
Thank you,
basically
sir.
agenda is variance of x plus variance of y minus two times of covariance of xy.
Covariance x y. Yeah. Yeah.
Since it's a zero, then it's a I mean since it's
Right. Right.
independent, then it will be zero. That's another case. One
Okay.
important case you can think about variance of x minus y is there, right?
Yes, sir.
So can I do variance of x plus minus 1 times y,
Yes, sir.
right? That means what variance of x plus minus 1
Minus one
square,
time. Oh, got it, sir. Understood,
okay?
understood. So it will
So
become one. Huh.
1. So it will
Yeah, yeah,
become
yeah.
variance of x plus variance of y
Right.
by the
Yeah.
property which you have to. So 9 plus 9, which
Mm.
will be 18. Okay,
Okay, sir.
Sir,
clear?
how we got that minus 1 is square there?
Suppose you have minus times of x.
Hmm.
Can I write down the same things minus 1 into x?
Hmm.
With the same thing I have done.
1 minus 1 whole square, you are saying, right?
Okay, one second, one second. What is this one?
A square, okay.
Okay, so instead in the place of a I have minus 1 times of y, so it will become
So we
minus
are
1
squaring.
square. Okay, good. So keep
Okay.
in mind these kind of properties that will help you while solving the questions and all. Okay, any doubt from this or should we move?
Sir, in general,
Uh-huh.
with regard to the variance, like if you're trying to identify it based on a distribution,
Uh-huh.
you can't use like in continuous uniform you have b minus a whole square by 12, but that
12.
doesn't work for discrete uniform distributions, right?
Yeah, that's
Okay.
that's separate for the continuous random
Okay,
variable.
sir.
Okay,
Yeah.
so for discrete, if you remember, that's good. Otherwise you can compute manually, right? Because
Yeah,
for
yeah.
the discrete, I think expected value will be, if it's a 1 to n, 1 by n, 1 by n, so it will be n plus 1 by 2, if I'm not wrong.
Yeah. Yeah,
Correct.
yeah. N plus 1
So
by 2.
Yes, sir.
similarly, you can calculate the, like, see, suppose x is 1, 2, 3, and so on, and probabilities for each value is 1 by n if it's a discrete uniform, right? So what will be the expected value of x? So expected value of x will be 1 into 1 by n plus
Hmm.
2 into 1 by n, and so on,
Yeah,
plus
yeah.
n into 1 by n.
1 by n.
So we
So
got 1 by
1
n.
by n into n into
So
n plus 1 by
that's the
yeah.
sum of n natural numbers, right? So
Yeah.
it will be n into n plus 1 by 2. So we got, yeah, n plus 1
N
by
plus 1 by
2
2.
expected
Hmm.
value of x, right? So
X.
what you have to do, expected value of x square. So it will be 1 square into 1 by n, right? Plus 2
Yes, sir.
square into
Yeah,
1
yeah.
by n, right?
So you have to
Plus
use the square formula. Okay,
so
sir.
square of the
N
first
plus 1
n natural number.
plus 2 by 2. No?
So 1 square plus 2 square plus so on plus n square. So I think it's if I'm not wrong,
And
6
in,
into
6 comes here.
n plus 1 or 2n plus 1, I think.
2
so
n
it's
plus
n into
1
n plus 1 into 2n plus 1 by 6.
by
Okay,
6.
okay, okay, by 6, right? That is right. So n will get cancel out, right? So you will get n plus 1, 2n plus 1 divided by 6. So now just apply the simple definition of
Yeah.
variance. So expected value of x is square minus expected value of x whole square, right? So
Yes,
here
sir.
you will get n plus
N
1,
plus 1 common.
2n plus 1 divided by 6 minus n plus 1 divided by 2 whole square, correct?
Ha. Ha.
Let
Ha.
me add a page, just a minute. So from here I can take 1 n plus 1 divided by 2 as a common, right?
Yes, sir.
So it will be 2n plus 1 divided by 3 minus n plus 1 divided by
2.
2. So n plus 1 divided by 2. So from where you will get 4n plus 2 minus 3n minus 3 divided by 6, right? So it will become n
Yes.
plus 1 divided by 2, and it will become n minus 1 divided by 6.
6.
So it's n square
N
minus
square
1
minus 1 by
divided
12.
by 12.
Yeah.
Okay, that's correct.
Yes, sir. Correct.
Okay, okay, no problem.
Okay, sir.
Sir, question number 5.
Question number 3. Fair coins are tossed. Find variance of x, where x is the number of tails that appear. Okay,
I took it like binomial and calculated, but I am not getting the value.
you're not getting the value. Anybody?
So I did the same way. I got the answer actually.
Okay, so 3 fair coins are tossed, right? So what is the value of n? 3.
3 years.
And it's the fair coin, that means probability is half.
1
Right?
by 2, 1 by 2, and 1 by 2.
Okay, so what should be the answer? 3 divided by 4. 0.75 is the answer.
Yes, sir. Yes, sir. Yes, sir.
Yeah, it's 0.75.
0.75 is the answer. 3 divided by 4.
Yes. Okay,
3 coins are tossed.
one second. Okay, so suppose I'm saying x is following binomial distribution with n comma p. What is the meaning? Means I'm performing the experiment n number of times, correct?
And
with
probability of success is
with,
P.
with success probability p. So here I'm doing the experiment 3 times,
Hmm.
and for each time I have only 2 possibility, either success,
Yes.
either failure. That's the definition of binomial, right?
Yes.
So can I say it's a 3 comma and p is the half because it's a fair coin,
Yes, I took this right.
correct? What is the variance of x in case of binomial? Npq.
And P times
Yeah,
1.
1 minus p. N is 3, p is
Hmm.
half, 1 minus p is again half, so 3 by 4 it's a
Okay.
0.75.
Then where I was going wrong, I don't know
Okay.
where. Okay.
Okay, so if you're going somewhere wrong, so what you can do, just cross check again. I mean, it's not like I'm denying to tell you answer. It's just a simple kind of process. Suppose you are making mistake, right? You are getting wrong answer, then try to see where are you. So what will be the things you will be able, if you are able to search, I mean find your mistake, right?
Hmm.
Then you will not repeat the same thing in again, I mean in again in any other question or in any other situation and all. Okay,
Hmm.
so
Okay.
again, if you are still facing any difficulty, then you can ask in the session, you can post on discourse anywhere. There are a lot of opportunity to ask it out. Okay, no problem. Okay,
But
is
most
this
of the
clear?
questions, sir, that I am asking, I
uh
tried it a lot.
No
Means
problem, no problem. I'm not,
maybe
you see, I'm
mine was.
not, yeah, I'm not denying to giving the answer, you guys. I'm just saying the what should we do in
The
normal
approach.
procedure. That's why it's not
Got it.
any problem to tell the answers with you.
Hmm.
Okay, so let's move to the next lecture. Concept of next lecture. I think it's covariance, if I'm not wrong, right? So covariance and its properties and all, right? So as you can see, covariance we have discussed just a few minutes before, right? So what is the covariance basically?
Expectation of return.
Mhm. Okay, so covariance of x comma y is the, I can say, expected value of x into y
Minus
minus
X, Y.
expected value of x into expected value. This is the one formula.
Yes.
Another one is expected value of, I can say, x minus
X minus E
expected
of X
x
and Y minus
into
E of Y.
y minus.
Y minus expectation of y.
So can you see carefully? Suppose I'm saying covariance of x comma x. That means what? That means
The
expected
variance of
value of,
x.
It's
yeah.
variance of X.
So it will become variance of it's a x. So this is the nothing but the expected value of x minus expected value of x whole square. So this is covariance. See, covariance is for two random variable, right?
Hmm.
We are
Yes,
okay,
sir.
and a variance is for the one random variable. Okay. So covariance is defined as like this. So there are something when covariance will become positive, when covariance will become negative and all. Okay. So simply if okay, so we have discussed about covariance is covariance will become zero. That means what?
So they are
It's
linearly
linearly
independent.
correlated.
Linearly
Yeah.
uncorrelated, right? But there
Hmm.
may be some dependency between those two random variables, right?
Hmm.
Okay,
Yes, sir.
when covariance will be positive and negative?
Positive correlation,
And
covariance
negative
is positive.
correlation.
Negative
Mm.
correlation.
Okay, only then covariance will be positive and negative.
Then there is
Yes, sir.
strong association between.
That's the different thing. Strong
That's
association and all
value.
means you can do in different scenarios actually. Okay. Okay. Let me clarify one thing. So covariance is something. If you remember, so covariance of x comma y we are defining as like summation of xi minus x bar if you remember into yi minus y bar, right?
Yes.
Right. Okay, this is something we can do, which we have discussed in stats one also, right?
Yes.
Yes, sir.
Okay, so why I'm doing this so that you can get an I mean you guys will get an idea about when covariance will be positive and covariance will be negative, right? So suppose I'm drawing this line. Okay, it's not exactly straight, but treat it as straight one. Okay, so suppose this is okay. This is your x-axis and this is your y-axis, and this is suppose your x bar and this is y bar. Okay, so far it is. No.
Yes, sir.
So okay, what tell me what about xi minus x bar here?
It'll be negative, sir.
It will be
Negative.
Less
what
than
about
zero.
y minus y bar?
Less than zero.
Less
Less
than
than.
zero, right? And since it's still linearly, so suppose I'm getting like this. Okay, suppose points are scattered like this. Okay, just usually. And what about this part xi minus x bar
Greater than zero.
Greater than 0.
and yi minus y bar?
Still less than zero.
Less
Still
than
less
0.
than zero. What about this part xi minus x bar,
Greater.
Greater than 0.
yi
Y
minus y bar?
greater.
Greater than 0.
What about this part
X is less than zero and Y is greater.
yi minus y bar is greater than zero? Now, so we are considering the product of these two, right? Tell me what about product of this part? Let me use another color. Product will be greater than zero because if you are
Yeah.
multiplying two
Yes.
negative quantity minus 2 into minus 2, I will get 4, right?
Hmm.
So these two are negative, right? Okay. What about product of uh, just a second. Okay. So what about product of this quantity?
Negative.
Product
Negative.
is greater
Negative.
than zero. What about product of this one?
Positive.
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 And what about product of this one?
Negative.
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 Okay, that means what? If your x minus x bar into yi minus y bar tends to be positive, right? Or I can say when x is above or below its average, right? When x is your above or below its average, I mean simply if your x and y are in this region and this in this region, then your covariance will be positive, right?
Yes.
Correct.
Yes.
Okay, so simply can I just try to relate this one? When my covariance is positive, Sarth, yeah, thanks. So see, can I say I'm saying covariance of x comma y is positive when if let's say x minus expected value of x and y minus expected value of y should be positive, right? Right.
Yes,
So
sir.
when this product will be positive if x is above or below its average, right?
Yes.
And y is also
Above or below.
Y is also above and below is average, right?
Hmm.
Then product will be positive. Is this clear?
Sir, they should follow the same sign also.
Same
Means
sign.
that
That's
also
why
will
if
be, sir.
see if that's why it's both are above, then product are
Hmm.
positive, right? Both
Hmm.
are below, then product is positive, right?
Hmm.
Product is positive means covariance is positive, right?
Yes.
Now, I mean this point is clear to everyone.
Yes, sir.
Yes, sir.
Okay. What about covariance x comma y will be when it will be in negative?
When they're opposite, like if x is above and y is below, or
Yes.
ulta.
So x minus x expected value of x and y minus expected value of y should be negative. Product of these two negative. When it will become negative? If similarly x is above or below its average and y is
Above or below its.
below
Below or above its. Right.
Below or above.
below of its average. Now this point is clear to all of you.
Yes,
Yes,
sir.
sir.
Okay,
Yes, sir.
no doubt. So that's why I draw this one so that you guys can get a clear idea about this one. Okay, no problem. Let's move ahead. So there are some properties of covariance of x. As I have told you, covariance of x comma x, it will become variance of x, right? One formula is also this is another type of formula. Expected value of x into y minus expected value of x into expected value of y, and it's also symmetric, right? Covariance is symmetric. Symmetric means covariance between x comma y will be covariance between
Covariance of y comma
Y,
x.
Y,
X.
x.
okay.
Yeah.
So there will not be any difference if I will multiply y minus y bar first into xi minus x bar, right?
There won't be
Let's
any difference, yeah.
Yeah, there will not be any effect.
Sir,
And
here x and y which we are using, those are the values that random variable are taking, right?
it's a random variable.
Means it has a lot of values, so we
Yeah,
have
it's
to take
every
each of the
random variable
value
has
and then.
a range. Every random variable will have some range. Okay.
Hmm. Like in
So,
variance calculation,
hmm,
I think in variance, no, I think in means covariance only, we multiply it with the probability also, so that comes from the expected value part.
yeah, that's why. So that's covariance has been defined, right?
Hmm.
So if you're going to calculate this part, so you have to multiply each value of x into y into probability associated with I mean joint probability for value of x as well as value of y.
Why?
Okay, so there is some covariance property of covariance for linearity and all. So tell me covariance of, let's say I'm saying x comma ay plus bz. What it will be?
Covariance of A
A
square
times
Covariance,
covariance.
A
A
times
of
not
covariance
A,
of
covariance.
sorry,
Okay,
A
A
covariance
square
x comma
covariance
A
of
S
X.
times
plus
Yeah, yeah.
B.
covariance of X
Uh,
comma Z.
No,
B
plus.
covariance x comma z.
x comma g.
Z.
Okay. Okay. So what about covariance of ax plus by comma g?
A
A
times
times
covariance
covariance of
of
Covariance of
X
x
comma
X
Z.
comma
comma
j
Z
plus
plus
b
B
times
times
B times
covariance
covariance
of
B
Y
covariance of
comma
Y
Z.
covariance
comma Z.
y comma z.
y comma g. I think. Okay. So another one is we have done that covariance of I mean independence of two random variables, right? So covariance of x comma y equal to 0, right? So as we have discussed, how we will get the covariance at 0? Simply if I'm saying x, two random variables x and y are independent, that means expected value of x into y same as the expected value of x into expected value of y. I think we have discussed before. Let me do it again. So covariance of x comma y will be expected value of x into y minus expectation of x into expected value of y. So I can put this value here. So expected value of x into expected value of y minus expected value of x into expected value of y. So this will become 0. So this
Zero.
is 0. That means they may be, I mean, see, there is two things. If I'm saying x and y are independent, right? Then covariance will be 0. Okay?
The reverse is not true.
Reverse is
Reverse
not
is not
true.
necessarily true.
That's what I'm trying to explain here. If I'm saying covariance of x comma y 0, then I can't say x and y are independent. This will not apply. X and y are independent. There may be some dependency like y is equal to x square and all, but these two are not independent. If covariance is covariance of x comma y is 0, right? But if x and y are independent, then covariance will be 0. It's for sure. Okay, is this clear? This part is
Sir,
clear to all of you?
I was not
Yes, sir.
getting this. Means,
Okay, one second. I told you if x and y are independent, then this part will be there, right?
yes.
And this part is there. That means covariance of x comma y is 0, right? So we got x and y was independent. Then we got covariance of x comma y is 0, right? But you
Hmm.
can't say covariance. If covariance of x y is 0, then you can't say x and y are independent.
They may be dependent, but may not. Means, but it
Huh.
is not linearly dependent.
Correct, correct.
That only we
So
can say.
they may be dependent because there suppose there may be cases. Let's say y is equal to x square. For these two, you are getting covariance as 0, but there is relationship as y equal to x square. Okay,
Okay.
okay, okay. So is there any doubt from this lecture, or we can go further? I think we should move, right? Because next topic is correlation, right?
Yes,
Sir,
sir.
activity
Yes,
can
sir.
I ask?
Which activity?
3.5, I guess. In
Which
second question, I was able to do it, but we
Hmm.
have to calculate the marginal and then we have to go about it. Yes, we have to calculate the marginal,
Yes,
and then we have to calculate
yes,
the expected value, then
yes, yes,
variance, and then covariance of it. Is
yes.
there a shorter way to do it? Means like
No
by
shorter
just
way. You have to
identifying.
apply the concept of covariance. That's all. So marginal win for x equal to 0, it will be 6 by 12, right?
Yes.
So you have to do for separate 0 into 6 by 12 plus 1 into 4 by 12 plus 2 into 2 by 12. Similarly, for the expectation value of
Why
expected value
also?
of y.
Yes.
And for the joint one, you have to do 0 into 0, 1 by 12, plus 0 into 1 into 3 by 12, plus 0 into 2 into 0. I mean, like that.
So zero we can skip, right? It
We
will.
can escape, but I'm telling the whole procedure. Okay.
Okay.
The same thing you have to apply. Okay, it's
Means by
huh.
directly seeing we can't say.
No. By directly we can't do anything.
Okay.
Okay. So let's come to the correlation coefficient. Okay, so anyone can tell me why is the correlation coefficient? Even though correlation covariance tells us the linear association between two variables, what's the need of correlation coefficient?
It tells the strength. A single value measure which tells the strength.
Okay, anybody else?
Correlation is dimensionless quantity.
Dimension.
There is no
Dimensionless
unit.
quantity.
There is no unit. We'll divide
Uh,
it by standard deviations.
Yeah, a row of x comma y is unitless.
Unit.
okay. Something else? Okay. What covariance tells us? Linear association of two random variables, right? Or linear strength of two random variables, right? Now, suppose for two random variables, you got covariance as let's say 72, and for different data, you got covariance x comma y as let's say 250. For another random variable, you got covariance as let's say minus 201, something like that. Okay, so but from these all things, are we able to do how much they are associated? What is the strength?
No, sir.
No, right? We there is no upper limit or lower limit to compare, right? How much
Yes, sir.
like how strongly they are associated, how weakly they are associated and all, right? So
Yes, sir.
Yes, sir.
because there is no upper limit or lower limit, correct? Also it has some units. So that's why correlation coefficient came into the picture, because correlation coefficient, if you see carefully, so correlation coefficient is defined as nothing but covariance between two random variables divided by standard deviation of x into standard deviation of y. If you see, so covariance, what will be the unit for this one? Suppose x is data of weight or y is the data of height. So your unit will be kilogram into centimeter, right?
Yeah.
Correct?
Yes.
For the standard deviation,
Yes,
it
sir.
will be kilogram. So unit got cancel out, right?
Hmm.
So
Yes, sir.
and limit for correlation coefficient is -1
Minus
to.
1 to 1.
That's why if you see, if I'm saying correlation coefficient between these two random variables is close to 1, that means they are strongly
Correlated.
associated, right?
Strongly correlated. Yeah.
Yeah, yeah, positive associated linearly and all like that. Okay. If correlation coefficient is 0, that means they are not associated. Correlation coefficient is close to -1, that means they are uh,
Negatively correlated.
Negatively correlated.
negative
Highly
correlation.
negatively correlated.
Yeah, yeah, close to -1, then highly negatively correlation. Strongly negatively correlated and all, right? So you get the idea what's the correlation coefficient and all?
Sir, what is the bound for covariance then 0 to,
No bound, no bound.
okay, it can be anything.
Yeah, it can be anything. That's why correlation is coming to the picture. Okay.
Okay, here we
So
are finding minus
hmm,
1 to 1.
hmm. Okay. So I think after this, I think bounce is there, right?
Yes, sir.
Bounce is there. Okay. So okay. So any one of you can
So
explain me
can you just write the list? I mean, I lost the list from S1. So can you write the list? I
list
mean,
of what?
I mean, sir, you remember you gave us the list of the
Okay, when
correlation
it
of
will be
lost
strongly
random.
negative associated negatively and
Sir,
all,
it's
right?
I mean, sir,
Okay.
strongly it's fine. It's 0.75 to 1 in either side. I
Okay,
mean,
okay, 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 okay.
-1.5
Let
to
me
Less
minus
than
1.
0.5, I think, is weak.
okay, let me write down.
Uh,
Let me write down. So 0.75 to R to 1. Okay. So it's strong and positive linear relationship. Okay, that means okay. And I can say suppose it's from 0.5 before 0.75, then moderate and positive linear relationship. Okay. R means correlation coefficient. Okay. Not minus 0.5. No one is not this one. Okay. So 0.5, that means weak and
Weak and positive.
weak and positive. Okay. Next one will be, let's say I'm saying minus 0.25 to 0.25. Then no
No
linear,
correlation.
no linear relationship. Okay.
So the middle twos are pretty confusing all the time.
Don't worry, don't
The
worry. It's
values.
no need to memorize all the things. Just for a rough idea. Okay, no need to memorize all the
Okay,
things. Okay, just you
okay, sir.
can simply say if it's close to one, right? 0.7 to 0.75 to 1, then it's strong and positive linear relationship. If it's close to -1, that means -1 to. Let me write down the thing. So next will be minus 0.5 to minus 0.25. That means simply weak and negative. Okay. And if it's suppose minus 0.75 to minus 0 point, that means moderate and positive, not positive, moderate and negative. If it's -1 to 0.75, that means strong and negative. Okay. Hope it's clear to all of you. Okay. Is this clear, sir? Now
So that would be other way around, right? I mean the last condition.
last condition.
I mean
yeah,
0.75 would be on the
0.75
left
to
and
1.
-1 would be on the right, right?
Ulta.
Now it's okay.
No, sir. I mean the signs. I mean the less than greater than you like -1 greater than equals to R you have written in the
Mm-hmm.
last. So
Okay, so
sir, R
minus,
cannot be ha sir.
Wait, yeah,
It would
correct
step on.
only.
it's a negative side, right?
Negative.
Ah,
So
right. Ha. Okay.
minus
Right.
1 is less than
I get it.
minus 0.75. Okay.
Yes, sir.
Oh,
Yes, sir. Got it, sir. I
no
got
problem.
confused.
No problem. No problem. No problem. Okay. Okay. So next is something if I'm not wrong, inequalities are there, right? That
Yes, sir. Markov
Markov
and
Chebyshev
Chebyshev.
inequality. Okay. Let me write down the things. Okay. So that's something Markov's inequality. Okay. So what is the use of this one? Anybody? Why we are doing some Markov inequality, Chebyshev inequality? Anyone else? No one?
Sir, I've seen Chebyshev in some derivation somewhere, but
Some derivation, right?
yeah, like it's a very powerful inequality.
I
That's
mean,
all.
why we are doing the things? Like, see, we got correlation we are doing because we can compare the things or how much association is there, right? We are doing the covariance for two random variables. We are doing the variance to know the spreadability there, right? We are doing the expectation to know about distribution. I mean, distribution of random variable in a single number. So what's the use of this all inequality? Anybody? You can give any idea. Don't worry about it will be wrong and all. No worries. No one?
Sir, it
Okay,
is for
how?
the upper bound calculation, right? I mean, probability for a non-negative function to find the
Mhm.
upper bound. I mean, for Markov's inequality, I think.
Okay, yeah. So basically, idea is we are able to find an bound for that probability. Okay, suppose I'm interested to know. Tell me probability of x is taking value or less than or equal to or greater or equal to something, right? Then there will be one bound. Yeah, the this probability cannot exceed this value or this probability will be at least from this value, right?
Yes, sir.
So to get an bound for these things, so Markov inequality is defined for a case like suppose your x is a discrete random variable and it's taking non-negative values, okay, and with a finite mean. So probability that x will be greater or equal to some constant, okay, it will be less or equal to mu by c. What is this mu? This mu is nothing but expected value of your x. Okay, so that means for this condition I will get one upper bound which is nothing but mu by c. So with the help of this Markov inequality, one important inequality which is Chebyshev inequality, so we can get with the help of this inequality, that's Chebyshev inequality. Okay, so for that what we have to do? Anybody? Okay, first of all, should we do the derivation of this one or it's okay for everyone? I think derivation has been done in the lecture itself. Okay. So what is the Chebyshev inequality?
Mod x minus mu.
Uh, Chebyshev inequality. So this Chebyshev inequality very, you can say, we are using in a wide range actually. Okay. So Chebyshev inequality is defined as suppose mod of x minus mu. Mu is the expected value of random variable x. Suppose this is greater or equal to k sigma. This will be less or equal to 1 by
1 by k square.
K
K
square.
sigma. Okay, so this is form. Okay, so how we can get this one? So here you can say x is the discrete random variable. Okay, and taking non-negative values. Okay, so taking non-negative values. So that means what? Can I replace x as the x minus mu square?
Yes, sir.
Okay, suppose in the place of x I'm taking x minus mu square. Okay, and in the place of c if I will take k square sigma square. Okay, then can I apply this thing in Markov inequality? Because this is something positive values, right? This is also
Yes, sir. Yeah.
okay. Are you getting what I'm trying to say here? See,
Yeah, yeah, yeah.
x is
And
taking
yeah, yeah.
non-negative values, right?
Yes,
If I
sir.
if I will do x minus mu whole square, then I will be like it will be non-negative, right? So
Yes,
can
sir.
I do if I will use the Markov inequality? Can I write down this x minus mu square greater or equal to, in the C, in the place of C, I'm doing k square sigma square less or equal to, in the place of mu, it's the expected value of x, right? So expected value of
X minus mu whole square,
x
which is
minus,
variance.
which is
So
variance,
sigma
divided
square.
by
K square,
C.
sigma
So
square.
divide by k square sigma
K
square,
square sigma square.
So
right?
sigma square get cancelled out.
Correct, correct. So can I write down these things if it's square one? Can I write down mod of x minus mu if you will take square root?
Yes, the only positive thing you're taking.
Only positive things, right? So this will become, this is the variance of x divided by k square sigma square, right? So variance of x will be sigma square divided by k square into sigma square will get cancelled out. So we got 1 by k square, right? Which is nothing but Chebyshev inequality.
Yes.
Okay. Did you get the idea? How we can, how we are using the Markov inequality to get the Chebyshev inequality?
Yes, sir.
Okay.
Yes.
Okay. So in the place of k sigma, if I want to use a single, I mean, right? So can I write down that these things mod of x minus mu greater or equal to c, right? So can I write down these things as what it will be the upper limit?
Variance.
So what we have done here, we are using c in place of k sigma, right?
Yes, sir.
Okay. So here we have done k square. So k square means c square by sigma square, right?
And sigma
Yeah.
square.
So 1 divided by c square by sigma square. So we'll get
Sigma
sigma
square
square
by
by
c square.
c square. Okay. So basically, I like this form of the inequality because it's something relatable. Means probability of mod of x minus mu greater or equal to c less or equal to variance of x divided by c square. So you can remember like this. Okay, so this is the for upper bound. What about lower bound? So I have to change the inequality sign, right? So this is less or equal to c, greater or equal to 1 minus variance of
1
x
minus.
divided. Okay, so far it is clear to all of you.
Yes, sir.
Okay,
Yes, sir.
Yes, sir.
any doubt related to these two inequality and all in the question or something? Or I think you covered all the concept, right? If I'm not mistaken.
Sir, this inequality, I was not able to understand anything. Means I think that I haven't watched the lecture, that's why.
Okay, okay. So what you can do, just watch the lecture video. So this is something like to get an upper bound or lower bound, right? Okay, to get an idea about. Okay, so here what is the funda? You will get idea. This probability will not exceed this quantity. Okay,
Okay.
so this is the upper limit for this particular case. Okay. Similarly, Chebyshev inequality we are using a lot of times. It's something very important kind of things. Okay. So this is something you will get as a upper bound because this is the, this inequality is less or equal to by this variance of x divided by c square.
It will be always less than this
Ha
value
ha.
that we will be getting.
Correct. And this should be the, this is the lower bound. Lower bound means it's a, this inequality is greater than or equal to by this quantity. Okay. So just rewatch the lecture video again. You will get a clear idea about it.
Actually, I haven't watched that video, so
Okay, okay,
maybe.
you can watch. Okay. From where I think you are, you getting any a basic idea about this one? Okay.
I understand that we are
Ha
means binding the probability like how
ha
you
ha.
have
Ha. Correct, correct, correct.
said that correlation will be between
There
minus.
is that condition. Your x is taking the non-negative values. Okay.
This mu is the
Expected
mean,
value of
right?
x.
Yes, expected value.
This
So
mu is
it's a
nothing but
mean.
expected value of
And
your
what
x.
is that c, sir?
C
C
is
is the
the
value.
C is a constant, which is greater than 0.
We can take any value, or it will be provided, or what?
It will be given in the question. That is the any, that can be any constant greater than 0.
So these two equalities are different. This is for the upper bound, right?
Ha.
And this Chebyshev's equality is for lower and upper bound both.
The same thing you can do in Markov inequality also. If you change the inequality, it will be 1 minus mu by c.
Okay,
Okay.
got it.
Okay. Is there anything else? Anybody wants to ask something? Any question? Any activity or something like that? Or is it okay for everyone?
Which lectures to refer from starts one?
For what?
for getting better understanding of week 3? Any error?
I don't think there is no need to go through. If you see, if you are familiar with the concept of expected value and expectation and variance, right? So I don't think you can. I mean, you have to go through the stats one. But if you want, then you can go. I will not deny. Don't go there. But if you are okay, then I don't think there should be any problem. Okay. Okay. So meanwhile, everyone has completed all the lecture video or still pending?
Sir, two videos are pending, like
3
correlation
months.
and bounds.
Okay. What about rest of the people?
I watched everything, sir. Only GA is pending.
Okay, GS then wait for 2 or 3 days.
So that's for the result, actually. I mean, till the deadline.
Yes, yes, yes.
But so one thing I wanna just tell you about
Uh-huh. Uh-huh.
the week 2. I mean,
Uh-huh.
there is an issue I'm facing. I'm not sure who else is facing the issue. So
Hmm.
I mean, after the week 2 submission deadline, I
Mm-hmm.
saw my GA. I got 100 out of 100, no issue.
Mm-hmm.
But next day, it got updated in my dashboard alongside my other courses. So
Mm-hmm.
everything was updated, but the stats to week 2 score is showing 0. But within the portal,
Same.
when I'm opening, everything is correct and it's 100 out of 100. So what is that issue? I don't
Okay,
understand.
okay. When did you check it this one?
Sir,
So
it's
Sir,
now also.
like
I also face the
like
same issue.
so
Okay, okay, no problem. No problem.
last I checked before I joined the session. I mean, it's going for from
Okay.
that time.
Okay, no problem, no problem. I will check. I will check with the team tomorrow morning. Okay, what is the issue?
Okay, sir.
And then we'll let you know. Okay, no problem. Don't worry if there is something updated and all. So, put. I mean, correct version of your marks will be updated. Okay, don't worry about that. Maybe there is some
Okay.
technical error and all. Maybe I don't. I'm not sure exactly, but don't worry about this kind of issue. Okay, I will convey to the support team. They will rectify it. Okay.
Okay, sir.
Okay, okay. If still there is some problem, you can post on Discord or let me know in the next session. Okay.
Okay, sir.
Okay. Okay. Great.
Okay,
Great.
sir.
Okay. Okay. Then is there anything else or else
Sir,
we
one thing
can
I wanna
stop the?
ask.
Yeah. 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 Please go
You
ahead.
can stop.
Sir, I solved the last activity. I don't remember the activity number. It
Huh?
was the bounding, I think 3.7.
Okay.
So I solved everything. So
Huh?
I just want to ask you one thing about the question 3,
Okay.
3.7.
Let me go there.
Okay.
Okay.
So,
Yes.
sir, in 3.7,
Hmm.
in 3.7, if I'm solving it in the traditional method, let's say I'm taking the mu, I'm
Hmm.
subtracting it in the inequality,
Hmm.
calculating, let's say minus something is greater than equals, not than, sorry, less than equals to x minus mu, whatever the mu is,
Hmm.
then that is less than equals to some value. So both the values are same with the sign opposite. So
Hmm.
we are taking the mod and then we are forming the Chebyshev. That's
Hmm.
fine to me. It's
Hmm.
totally fine. But whatever that C value, so you actually introduced the formula variance of x divided by C, I guess. No, C
Hmm.
square actually, right? C
Hmm.
square.
Hmm.
So sir, in such case, let's say I'm getting P of mod of x minus 100 greater than equals to 30.
Hmm.
So I can so I solved it in the form of, I found the, since it's binomial, so I found the sigma, sigma square. I calculated for sigma, that is standard deviation. So
Hmm.
k sigma equals 30. I have calculated k and calculated the 1 by k square. So according to the formula you have introduced, so
Hmm.
variance I gotta calculate. So
Hmm.
variance by my C is 30. So
Hmm.
it would be, let's say variance is 50. So 50 by 30 whole square. So I can calculate in such a way as well, right?
Correct. Correct. Yeah.
So it can be done. I mean,
Yeah. Yeah.
for
So
such
at the
cases.
end, you will get 50 by, if it sees, you say 30, so 50 by 900, that is 1 by 80.
So
Correct?
okay. So that's that was the query I had. So we can calculate such a way.
No problem, no problem. See, you can see 1 by 18 is the one of the option.
Yes, sir.
Okay.
It is.
Okay, you can do like that. So,
Okay, sir.
question is like your at least 130 or at most 70. So that means mu plus k sigma, or you can go by the formula. See, if you are getting confusion with the formula of C, then just go by the k sigma one. Okay. So then mu plus k sigma is 130.
And mu minus k sigma is 70.
Mu minus k sigma is 70, right?
Huh.
So if you subtract, then you will get mu will get cancelled out. You will get 2k sigma equal to 60, right? So k sigma is 30. See, even though what we have done, see what we have done in the previous example, we have just replaced k sigma with the help of C, right? Either you will go by with the help of this formula, or you will go by this formula. You will get the same answer. It's just a replacement of the sum quantities. Okay.
So just a modification.
Just a
In
modification.
the formula.
It's
Okay.
not like this formula is different from this formula. This formula I got when I replace the k sigma as C. Because, see, why we have done like this, because I like this one, because it's kind of easy to memorize, right? Yeah, mod of x minus
Yes,
capital of a greater or equal to C less or equal to variance divided by that constant square. Because sometimes uh, see what I made mistake sometimes. Let's say it's a k sigma, then I done divide by 1 upon k square sigma square by mistake. I mean, so that's why I'm
Okay.
using this one. I mean, I'm speaking
Okay.
frankly what I have done sometimes. So that's why I'm telling. Okay, so this is just a replacement of some
Okay, sir.
quantity. Okay, you will get the same answer.
Okay, sir.
Clear?
Okay, sir. Okay.
Okay, okay. Okay, then let me stop the streaming. If else, we can discuss it later also. Okay. I hope you got the idea about week 3 and all.
Yes, sir. Thanks, sir.
Yes, sir.
Yes, sir.
Yes, sir.